Hello students, the first experiment we are going to do is Orificemeter and Venturi meter. We actually discussed about the concepts of Venturi meter and Orificemeter in our class. During our class session, we have discussed under unit number 4. I hope you all remember whatever we discussed under the metering devices. Okay, basically this Venturi meter and Orificemeter, it falls under the classification of variable head meters. Okay, variable area meter, example is rotometer. Okay, so first we will start from Venturi and Orificemeter. So while talking about this Venturi and Orificemeter, I would like to explain you some of the concept which we discussed already in the class. So as far as the Venturi meter is considered, there are three portions available: convergent, throat and divergent section. I'll just show you all these things. Before that, let me explain all the concepts, basic concepts. So Orificemeter, it is also a similar kind of Venturi meter, but the obstruction of flow will be made by entering a disc at the center of the disc or plate. It may be a small orifice will be provided, so through which that small orifice the water will be allowed to flow. So both this Venturi and Orificemeter, variable head meters, the pressure head will vary across the two points where we are creating some obstruction, but cross-sectional area remains same. So this is what the principle of Venturi meter and Orificemeter. This is how the Venturi and Orifice is working. So both the meters used for the calculation of determination of flow rate, volumetric flow rate, okay, meter cube per second in SI units. So that is the thing we discussed in our class. Theoretical flow rate, the formula used to calculate theoretical flow rate either for Orifice or Venturi meter is like Q is equal to CV A1 A2 square root of 2GH and divided by square root of A1 square minus A2 square. So this is for your again understanding. I would like to remind this formula. Okay, so these are all the basic things. So the application of these flow measurement meters will be enormous. Like this flow measuring meters is very important to measure the flow rate. So it works based on Bernoulli's principle. So from the Bernoulli's principle, when you apply the Bernoulli's equation on either side of the 2 points, we will be able to get the equation required to calculate the discharge for both the Orificemeter and Venturi meter. So this is the Orificemeter you are looking in front of me. This is the Orificemeter you are looking in front of me. So the basic details like orifice diameter and pipe diameter will be given in the board. So let me show you later on during the calculation. So this is the orifice portion you are seeing here. This is the plate, orifice plate will have a small orifice at the center. Okay. So how this experiment is actually being done and how it is working, let me explain. So the water will be allowed inside through this inlet pipe. The water will be allowed through this inlet pipe. Okay, this is the pipe. Will get water from the sump. Okay, when we open this, the water will be allowed to enter into the inlet section. So here is where you will control the flow rate. So this is the valve provided to control the flow rate. Okay, right? So through which the water is allowed to enter into the enter through the orifice plate. Okay, so actually it is not transparent. The pipe is not transparent. The closed pipe is not transparent here. So it is very difficult for you to see the orifice plate which is provided in between, right? So we can imagine that there is a small orifice at the center, so through which the water is allowed to flow. So this is the one point where the probe is there is a provision provided to measure the upstream pressure, right? This is the provision provided to measure the downstream pressure. So we know already that in order to measure the differential pressure, we need to have an U-tube differential manometer.